In group 2A metals, metal oxides becomes less basic if you go from top to bottom. The reason is that because down the group metal atoms becomes larger. So for instance, this is larger than the beryllium. Larger atoms is actually more electropositive, and they can lose electrons more easily and form the ionic oxides. So this barium can give its electrons more easily than beryllium. Therefore, barium oxide is basic, but beryllium oxide the least basic chemical in our case. In transition metals, this is a little bit more confusing, since for the transition metals and late transition metals, basicity decreases from top to bottom. Heavier transition metals tend to have higher oxidation state and more covalent character in their oxides, and covalent oxides are less basic or even acidic, and moreover, as the oxidation state of the metal increases, the basicity of its oxides decreases. For instance, here we have a chromium and it is +2 charge. Here it is +3, and here it has +6 charge. And covalent oxides do not easily form hydrogen ion in water, and higher oxidation state causes stronger polarization of the oxide ion. This weakens the oxide's ability to donate electrons. So in here, actually, in chromium 6 plus causes an acidic environment, since it cannot donate its electrons, but chromium 2 plus is a base. In our case, chromium 6 plus is more electronegative. This is more electronegative atom than the chromium 2 plus. And therefore, chromium O₃ is the most covalent and least basic chemical in among these three molecules. And trends across a period from left to right in transition metals. We can think a periodic table. I'm just want to make a rough graph. In transition metals from left to right, for the D group elements, oxidation state increases and ionic character decreases, which causes to increase the covalent character. Here, ionic character decreases, but here, covalent character increases, and oxides becomes less basic from left to right. They become more acidic here and more basic here. For instance, if you look at the zinc oxide, which is about here, it is an amphoteric. But again, if you look at the titanium oxide, and titanium is around here, and titanium oxide, CrO₃, is both basic and acidic character.